I come from a beautiful medieval city of Tallinn, not the only one. There are like 3 speakers from Estonia today here. And I'm going to talk about the stuff that actually grew out of the pain of seeing many different projects where people actually don't know what working software is. So working software is something that was defined as in Agile Manifesto in 2001, when they said that working software is actually more important than comprehensive documentation. Of course, the community actually read something else from it, is that basically you don't need to document anything, you just need to write some code. So this of course is not what it was, and that's why in 2009 there was a next manifesto that said that not only working software is important, but also well-crafted software. So they actually tried to make it more specific and redefine it a bit. And that was also the time when we started our consultancy company in Estonia called Codeborn. And we used this well-crafted software in our tagline, because we thought that this is very important. So this is what differentiates us from other people writing software. Because then, 10 years ago, and now people still don't know what working or well-crafted software is. So yeah, let's try to define it, or look what does this term can contain. So it's, for me, the first and the most important, and this is also what the Agile Manifesto tells us about, is that working software should fulfill business goals. So otherwise there is no point of it existing. It also should have value for the users, and these are things actually connected together. And it also should be easy to use. So it's usability for end users, so meaning that software, if it's hard to use, maybe it's not a working software for somebody who is unable to use it. And is also, I don't have it in the list, but the accessibility is also here. So if a person cannot use it for some reason, that it's not working software for them. So it also, there is other types of usabilities here. So it should be easy to deploy. It should be reliable. So, and this is the usability for system administrators, for example, who actually run the software. And it should be also easy to monitor, audit, trace bugs, and easy to change and fix. And these are the things which are the usability for us developers. So it also should be easy to add features to. Also usability for developers, and actually the value for our customers who actually order the software development from us. And it should be easy to test automatically, of course, and it should enable automatic testing. And this is needed to keep it working, because working software, you can say that it is working at this point of time, but what will happen after I change it tomorrow? So if you don't have any automatic tests, then it can become a non-working software tomorrow. It's really easy. And ideally, all this list means that actually there should be no extra work for anyone besides changing the code and tests in a true working software environment. And this is what I'm going to talk about. So of course, these first things are the most important, that it's actually useful, but then all the people who are involved into changing this and maintaining this software, it should be easy for them, no extra work. And this is what will make this software really working. Uncle Bob Martin is a great guy. He has tweeted recently this interesting thing. So basically what he said is that that the working software is not as important as a changeable software. So he said that even if your software is easy to change, but it does not work today, it's easy to make it to work. But the other way around, it doesn't work. So you cannot if your software works right now, but it's not tested, it's hard to change, then it won't be working software tomorrow again. So he has a point. I don't agree with that 100%, but there's an important point as well. So the software actually, for us developers, it should be changeable, should be maintainable, should be easy to change. There's also a definition from the Agile community, like a broader definition, is that working software is fully integrated, tested, and ready to be shipped to customers. So basically it means that something that just you got it to work on your own machine is probably does not fill the definition of working software. I have also a theory that there is a pyramid of working software. So this is the only one that I found on the internet that actually matches my expectations. So of course the testing pyramid is really famous. So people know that, and actually the Maslow pyramid, who started all these pyramid things, so of the basic needs. And testing pyramids is very famous, that you need to have many unit tests and fewer, like more complex and more integrated tests. And the same with the working software. So, and the quality software, that it should, if the functionality is okay, then it's a basic need, of course, but it also should be that, and that. So, unfortunately, we all have heard this. So, works on my PC, machine, whatever syndrome. So, this is what we developers love to say. It basically means that you don't have enough tests, or you have a really handcrafted environment in which you build and run your software on your machine. And which basically means that it's either evil or unprofessional. I tend to hope that it's more of the unprofessional, not evil, but sometimes it can be the other way around. So it also means that it doesn't scale without automation. So you cannot like only rely on your own PC to make your software work. And we are not in this age of the computing when then you had only one machine where your software was supposed to be working, and now we have plenty of servers and stuff. So, and this is like an alchemy, like if we go in even further in history. So there was always a secret ingredient that was needed to make stuff run, and this is also true for much of the software projects that I see in my consultancy career. So there's always a secret ingredient that I need to know so that I can run it on my machine. So the developers won't tell it to you, even not in the README very often. So it can be some secret Spring or Maven profile that you forgot to include when building or running your application. It can be dependencies that should exist in my local Maven repo on my machine, and of course I don't have them. If I do just git clone and run it, then so they know that you need to git clone another repository and build it first, and then only the stuff will work. Then of course it can be hard-coded some configuration that there should be a database running on some particular IP address, and if I'm in the office, yeah, it works magically, but when I'm outside of the office or I'm on a plane, nothing works. So there can be some GNDI resources, getting back to the Java world, that need to be set up before I can even start running try running my application. Or some config params missing, and system variables, system properties, whatever I need to pass to get it running. So, and many other magic rituals that can exist to actually make the software run. And this is usually the result of either lack of continuous integration. So basically you are only running your application on your PC and maybe this particular server, and that's it. And it can be also, I have seen, a result of overly complex continuous integration setup, meaning that you need to, so it's so complex that you just cannot replicate it easily in any other place. So, and that comes to the doesn't work even on my PC syndrome that I have seen as well, and this is even worse, and this is where we are in many of the big enterprise projects. Microservices, you know, does it ring the bell? So you just have no idea how to run it all, how to start it. So you just git clone, you work on the code, maybe you run a couple of integration tests and they pass, then you think that hopefully my software will work, let's ship it. Maybe the QA team will find all the bugs or like get back to me that my stuff doesn't even start. So yeah, and how can you work on your software project in this kind of situation? And I've seen it even pretty recently, and some, sorry, Venkat is not here, so it was an Indian team working on a project, but it's not India specific at all, so I've seen it in many other countries as well. So, of course, microservices, Maven profiles, very complex configuration, everything like can contribute to this situation, and it will also makes you feel like that about the software, just want to back up from it, you don't want to touch it. So, smart guys at Heroku, who have used Heroku? Yeah, it's a really great service that actually exists for deploying your application. It's really simple. It's quite old already, for like more than 10 years, I think. And they have come up, they are completely not Java guys, they're Ruby guys, but they come up with this 12-factor so that you need to follow to make your apps actually working apps or working software. So there are some of them, but we will go through them hopefully, like who knows about 12 factors? Yeah, some people, not all. So let's look at them. But before we get there, I would say that there are these two tools that we now have, Git and Docker. They actually make it almost free to use. And of course, the third thing is the common sense, like the simplicity. It's these things, they make it very easy to comply with 12-factor apps. So it's basically Git, Docker, and common sense. And I would say that Git and Docker, they are both probably the best inventions in the last decade in software development. So this is something that we should be really grateful for to the creators of these things. And yeah, they provide almost everything for free from the 12 factors. But common sense is something that you still need to comply with these things. So Docker, basically, it fully controls your build and run environments of your app. So nothing undefined will leak in. So this will instantly fix the works on my PC problem. So it will work, if it works inside of Docker, it will work on any PC because the Docker's environment is really well defined. So it's, you just describe it in a really simple file format. And actually I've heard today, I think by Kevin, he said that Docker is basically a simple VM. I think it is as far from the truth as it can be, because Docker is nothing else, just an isolated environment. So there is no virtualization there. It's just an isolated environment where your app runs and nothing else. So, and Docker-compose is really nice file format, universal, which is really easy to describe your application in terms of many parts of it. That is actually widely supported by different tools, and it's really small what you get. So I recommend using that for like most of the stuff that you do. And even Kubernetes, which is like a de facto standard nowadays, unfortunately, it's not simple. It's not KISS. But so don't depend on it in your code. So just rely other people's sysadmins running the Kubernetes for you, and just make your app run nicely in containers under Docker-compose, and then you're fine. So the 12 factors, 1 and 2 are really basic ones nowadays. So they say that you have one version code base and many deploys. So basically you don't copy paste your code base, which was common at some point in history. And you explicitly declare and isolate all the dependencies also. So this is achievable by the Docker-compose, and if we use Java world, nowadays we use either Gradle or Maven or something to define our dependencies. Really easy, and I hope that most people do that. Of course, these dependencies should be available also for download. So if they disappear, then it's a problem. So if you want to have a local dependency in your local repository, that's a problem. But fear dependencies as hell. That's my addition. So the fewer dependencies you have in your project is the better. Because every dependency adds complexity, it adds a bunch of code in your project that actually you don't control, and you don't know what it is, and maybe at some point if it's somebody not maintaining it anymore, it becomes a burden for you. So for example, you cannot upgrade your Java version because you're still using some library that doesn't work on Java 14 or even 9 or 11. So fewer is better. No hand-tuned build-run environments, of course, and the Docker solves the problem of even the system utilities. So it provides everything in your base image. So it's the Dockerfile from thing. So who can write Docker files? Knows how to do it by heart. Really nice. So it's easy. Then the configuration and port binding. So they say that everything should come from the environment. So this is the same philosophy. One code and many deploys, basically. So your code can be deployed anywhere. It should run anywhere, basically, meaning that you should not hardcode any of the configuration environments. So it all should come from the environment where it runs. So no build time configuration. It's runtime configuration. So they also say that it's better not to have this test prod and configs in Git, because there can be many more environments after that, and plus there can be security concerns. But and Docker, of course, solves the port binding problem, so you can still bind to the port you like, but externally it can be mapped to anything, so it's really good. I would say that still you would need the default developer's configuration for good developer experience in version control. So basically you need to have your stuff running. It should be easy to contribute. So basically you do git clone and it runs. That's like you avoid a lot of problems that can be there. So that's meaning that there's a good idea to provide a working Docker Compose in the Git as well, so that people can take advantage of it. So backing services is something that your app depends on. So in microservices world, it can be a database or it can be microservices that you depend on. So these are basically runtime dependencies and should be treated as such. What they say that they should be attachable and detachable. Basically, you can configure your app to use any other database or like located in a different place. So it should be very easy to reconfigure your app to use the other runtime dependencies without changing the code and recompiling your app, of course, because usually there can be a critical thing that should be solved on production where you need to actually reattach something. So in internal or external, you should treat them the same. Basically, either it's your microservice or somebody else's, no difference. So Docker Compose is actually solves it all, again, for free. You just define all that you need. You define the environment here, and one trick that not all people know is that the docker-compose.yml, this is actually the file that this will be read by Docker Compose by default. So if you can always have your generic Docker Compose YAML, for example, that you reuse even for production, you can have it in the default file, and in Docker Compose override YAML you can add anything else that the, for example, production installation will not need. So you can add the port mappings to localhost, for example, if you need them. You can add some more volumes for easier, like log reading or whatever. So, and Docker Compose will use both files by default. So that's a really good trick. So then the build, release, run stuff. So basically meaning that you should strictly separate build and run stages, and one build for all. Meaning that you should always, you build your app only once, and it should be runnable anywhere. So you build, you compile it, and then you use the environment to actually start it in different environments. And this is where actually Maven fails you in many cases. So if you guys use Maven, do you use Maven? Do you like Maven?
Yeah, I like.
You like? Okay. I hate Maven with a passion, because I needed to use it recently, and it's so unflexible. It's, It's as bad as Spring, because in Spring you use annotation-based development, and in Maven you use the XML development. XML was never designed to be a Turing-complete language or something like that. So, but the worst problem with Maven is that it's pretty common to use these profiles to change the outcome of the build. So basically at build time you provided a profile that would copy some resources with different configuration and put them inside of your build, and basically there is no one build for all anymore. So you get different builds for all environments. You cannot you can never sure that the build that you have tested here is actually will work there, because it will be a different build that you need to run in production, for example. That's something that you should avoid definitely, and it makes working with it much harder. So I've seen projects where you need to actually rebuild it with Maven with some specific profile until it actually will run in my IDE. So that's crazy shit. You never expect that, or maybe someone would have. I don't. So for what Heroku guys also say, that no code changes in production. Of course, with Java it's much harder to do, fortunately. PHP developers still do that, and Python developers. And for us Java developers, it actually means that probably it's a good idea to avoid shipping the compiler with your application. So when you're building your running container where your application will actually run in production, make sure that there are nothing else there besides what is needed for your application to run. So this is really good thing for security and also for maintenance as well. So don't build separately for test and prod. So I've seen like many people have really strange Jenkins pipelines which are like, I'm building this for test and I'm building this for prod, and maybe multiply it by the 10 other environments and you're screwed. So what you need to do with Docker files, if you're not doing it already, the multi-stage Docker files is a really good thing. So you build it in one container where you have the JDK with the compiler and everything, and then you put the result of the build to another container which contains only the runtime edition without the compiler and everything else. And the smaller is this base image for the production container is better. So you can even use in Java, you can use JLink to actually build a custom JRE that only includes the stuff that you really use and need. So, and for example, when I do, there can be even more than 2 stages. So for example, when I'm doing the full stack development, I do write front end and whatever TypeScript, and for example backend in Java, I would build the front end separately in its own container. I would build Java server side in its own container, and then I will include everything that I need in the final container that runs in production. So then there is a process model for running your application. So for us in Java world, we have always thought that for concurrency we use threads. And threads are good, of course, but in most cases actually you cannot get away with only one JVM, only one machine where your app runs. Even for the redundancy, if one machine crashes, you always need to have at least 2 copies running, meaning 2 processes, and meaning that you should rethink your concurrency if you are accessing any shared resources. So it also means that there should be a quick startup and no local state to actually, when something goes down, you can rerun it very quickly and it will be ready in like a couple of seconds to accept the traffic again, this kind of thing. So traditional Java development wasn't like this, unfortunately, and still is not for many people who like Hibernate, for example. Hibernate will always reduce the startup time of your app for many seconds, and sometimes even can be like 30 seconds or even a minute, which is choose your frameworks wisely so that will not kill your productivity and startup times. So, and then you can scale it very easily and automatically. So the orchestrator usually should do it for you. You shouldn't do it in your code. So, and you can even have different process types, which is also not very common in Java world. But for example, for the batch jobs and for the web application, you can use actually different processes. In Java, we would usually use threads or something in the same JVM, but it's better to keep them separated so you can scale them separately. For example, maybe you need only 2 nodes for the batch, but maybe like 10 nodes for the web application and something else. So it's good to have them as separate processes. And the crashes and the restarts, this is something that the orchestrator should provide to you, like the Docker daemon. And of course, it means that no Java app server. So who is still using a Java app server? Some kind of. Yeah, some people. I'm pretty sure you're not happy about that. And I see some companies, bigger ones, with architects and smart people. They say, hey, your app should work on WebSphere, and let's disaster. You cannot guarantee that your code will work if there is such a monstrum actually in front of it. So you never know what box does it contains until the users will actually reach your code that you have written. They're very slow. I don't know why people use them still, some. So disposability, of course, is a really critical feature of containers as well. And I think that containers, actually, the Docker got its inspiration from here, is that you don't hold any local state inside of the container, and it can be deleted and recreated at any time. So it's easy to recreate it on your own machine while development, and it's easy to recreate it on any physical machine while you're scaling it up or down and whatever. So nothing should be local, and that's a good thing for good working apps. So no dependency on the environment. So of course you can have some local cache or something, but this cache should not be persistent. So you should never think that it will be there with the next request from the user. So, and of course that brings the easier releases and scale up and down, and of course it also means that Hibernate and the Spring complex setups are not a good thing for your app, so think. Sometimes Spring is not such a bad thing, but still it has so many annotations that are really hard to test, and which it does for you, and you have never sure that if I add this annotation here, will it work or not? And maybe I usually use the debugger to actually check if it works. And for workers, for batch jobs that you actually do the stuff that you need to do in the background in your application, the idempotent operation is really important. So because all your processes should be disposable, so they can basically be crash, and they can crash, and this is like the reality. Your software and stuff can crash at any time. And if you're designing your system to be disposable, so that it can start up from any state and continue where it left on, so you're also building a very reliable system in this case. So you don't need to help it and fix it manually if it actually crashed at some point. And meaning that all the batch jobs that you are having, they need to be idempotent. So no matter on which state do they run, they should still understand what is done, what is not, and they should finish their operation and have the same result. So this is not hard if you just think of it, and thinking is really important. So then there is the dev-prov parity. So the development, staging, production, all the environments as similar as possible. Of course, this will have fewer problems, unexpected problems, if you run it everywhere the same way. And again, Docker helps here a lot. So logs. Logs is something that you should be treated as event streams, meaning that they should always provide context. So and not just a random spam that in some projects I see. People just flood the logs with something which is not really useful. While developing, they add some logger info and sometimes logger debug, but because debug is turned off, so they switch it to info, and then you get so many logs without context. Every single line is not relevant anymore, and it's really hard to see the important things in the logs when something doesn't work. So what also these 12-factor apps say, that there should be no file management. You just write all your logs to standard out. And so actually the point of the 12-factor apps is that you use the your like Unix environment as much as possible, what was designed like back in the 60s, and it works pretty well. You don't have to reinvent that. And this is what also the Docker and the containers then make it easier to go back to the basics again and use simpler things. So it should be an outside like orchestrator responsibility to actually manage your logs and go, copy them somewhere and whatever and store them. So it's also convenient for development. If you just run your app and it logs to a standard out, you see it instantly while you're developing. So, and the last one is the admin processes. It's something that sometimes you need to do some things like once, like prepare something, and you should be able to actually go inside of your apps and run something in the context of your app and have the same environment. And with Docker, again, it's really easily achievable. With Docker exec, you go inside, you do whatever you need, and you're done. So, having said all that were the 12-factor apps. So your app should also start out of the box. So it's you can say that battery is included. So right after clone checkout, and both from either command line when you're just trying it, and also from the IDE. So yeah, the IDE is now the default IDE. So I put the extra letter there. So but basically it should be easy to also run your code under debugger and everything. And if you have a really cool and hand-tuned Maven build script that actually can run your application, but you cannot run it from the IDE, it meaning that it actually, you will like debug it with loggers, and it will be actually hard for you to do it. The productivity of finding the bugs quickly will go down. So there should be no magic wand involved in starting the app. It should just start, just work. So then there is the developer experience and the usability for the developers. So you can look sometimes on many open source projects, because open source people, they know that contributing should be easy. If it's not easy, no one will contribute. So, and why in enterprise you think that if it's okay if it's not easy to start you up? It's because everyone are paid to still figure it out, but that's not like you will lose the productivity, of course. You lose the motivation, like I do. So of course you need the good IDE, the best possible IDE, the best tools and scripts that you probably should write and share with your team. And you should have a really small, concise README that will define the basics for the newcomers. So how to start with the app, and it should be like basically several lines of text. So if it's long, then something's bad. So you should not, for a good developer experience, you should not wait for something. So if you're waiting for your app to compile, it's bad. If you're waiting for your app to start, it's also bad. If you're waiting for your tests to run for too long, it's also bad. It kills your productivity. It makes reduces significantly the amount of changes that you can do in a given amount of time. So Apple is also an interesting experience of really UI and usability focused company that actually is pretty bad with developer experience. So they think that the developers actually should actually do a lot of things to get stuff going on, like generating profiles, registering stuff and whatever. So a good developer experience example would be like, I do git clone, I read the README. For example, it says that I need to start the database to be able to run the app. Okay, I do that. That's easy. And then I run it, and it works. So that's what would make anyone coming to your project happy. And even you, if you switch the machines like we do with pair programming, we don't have any personal machines. We just like go from one machine to another, and everything should work on every new machine. And it just works, and the test should also just work. So you just run this, and test should work. It's very obvious, isn't it? But not for all projects. I don't get why. So for many projects, it just doesn't work like that. But tests, of course, they should just run, and they should run fast. This is really, really important. I cannot like say more stress it enough. So the test should also run from the IDE and under debugger, because sometimes you need to maintain code written by others. Sometimes the code is not the best, so it's easier to still see it in the debugger how it works. And this is critical. So there are so many projects that actually, because they have the continuous integration, the tests work from command line, from Gradle or Maven. But then you just open one test class and hit run in the IDE, it will just fail miserably, because you haven't specified some environment variables or anything else, and the working directory is probably wrong or whatever, and it just doesn't work. And I need to spend my time and figure it out instead of actually fixing the actual bug or like adding a new feature. So the test should run one by one. It's critically important, because when you see from continuous integration that you have like 3 failing tests, you need to be able to actually rerun them quickly and see what's wrong. So no external dependencies, no manual, no string mapping profiles. And TDD is actually the tool that can help you here very well. So TDD actually is nothing else than it gets you to see that your code works every minute or so. So you're not coding for longer than a couple of minutes without either running your code, and this is what it gets you, among other things. So fast tests, when I say fast, what I mean is that, for example, 30 seconds for 10,000 tests. This is fast. This is how well you should actually cover your code. So this is a real example from one of our projects. We worked hard to make them fast, because by default, if you like think, oh, the test containers are so good, so easy to just spin a couple of Docker containers, and they all take 5 seconds to start, then multiply 5 by 10,000. Even multiply 10 milliseconds by 10,000, and you get what I mean. So you will lose time every time you want to make sure that you haven't broken anything. And this is what tests you give. So they give you the feedback that you have changed something and you haven't broken anything. So unit tests are fast. That's why most of your tests should be unit. They test on your code only. So it's in most cases it doesn't make sense to use the frameworks that would spawn up an external service as a real HTTP server, and you would then talk to it from your tests using HTTP protocol. It doesn't make sense, because HTTP protocol works. You don't have to think that it may break. You need to test your code, and your code is not usually you're not implementing the HTTP protocol or any other protocol. So just unit test your code, and then have a couple of quick integration tests as well that will show you that everything together works as well. So for example, one advertisement at seleni.org is great for writing UI tests that glue everything together, because anyway you need to have some acceptance test in the end. So database migration is also one important topic here, is that and like any other environment preparation, it should be automated. So of course no hand executed SQL scripts in your database, but they should be part of the code, of course, to build the environment from scratch. So even if your app doesn't own the database it accesses, it still needs to have some access to the scripts to actually build this database from scratch while you are testing it. So that's probably meaning that you should, if you use any shared databases, you need to extract this database creation scripts to some shared place where you can reuse it, either with Git submodules or whatever. So, and really important that DB migrations should run at runtime, not at build time. So it can be a separate process in production, or they can have a separate user, which is a good idea for security, that has more permissions to create objects in a database, but not build time, because there is one build for all. And Liquibase and Flyway are good tools, both of them, and I like Liquibase more. It's more flexible, but not their Maven or Gradle plugins. So these are useless. Don't use them because they will they will work only at the build time. And build time, you cannot take your ready-made application and run it anywhere. So this is all about actually fast turnaround and feedback, which is Agile is all about. So you need to know instantly if you have broken anything. You should actually control your project, and when you control it, you actually enjoy working on it. So when you don't control, you don't enjoy it, and you want to leave the project, you want to go to another project and whatever. So think of it. So you need to strive all the time to make it the developer experience better, the feedback quicker. So it will keep your motivation up actually, and that comes to the complexity as well. So I don't get why do people like complex solutions. Very often the first solution that you find is actually more complex than it has to be. Very often you want to build something very complex to solve something simple, or you just want to try out the new cool like framework, and it's actually like it's called resume or CV based development. So very often there are too many moving parts, and making the systems actually unreliable. So fewer microservices in most cases is better. This is what also the Nikolai told us before today. So invest time, and what I would suggest you that invest time into simplifying your code and solutions. So this will pay back multiple times, because if you make your stuff complex, and very often the initial solution when you make something to work, it's more complex than it has to be. And then invest some time always, like how to make it simpler. Maybe I don't need this complexity just now, maybe I will need it later, but I don't know yet what will happen later. People are not very good at estimations. So you just first make it work, then make it clean and simple, and only then you say that it's done. So it's not done until you, if you just made it work and not made it clean and simple. So of course the Einstein, they say that, he said that make everything as simple as possible, but not simpler. Of course you should not go the other extreme as well. So what brings us also to the clean code. So clean code is something that should be there. It's like you're cleaning your hands like every day or before a meal. You should also think about cleaning up your code, because your software actually will live for longer in the code that you have written that probably you expect. So in the book by Uncle Bob, which is called also Clean Code, really the Bible of the software developers, I would say. There's also the Boy Scout rule, and I hope that it can be applied to girls as well. So leave the campground cleaner than you found it. So basically meaning that even if you see something that is not bad, not too good in your code that a team member has done, you need to always stop, and if you see it, you stop and you pick the garbage up, basically. You fix it. Very often there are very simple changes, so I very often change code while reading it and making it cleaner, better named variables and whatever. So avoid being negligent and craft your code. So what we are doing is actually a craft, and meaning that our code is actually it's like the stuff that we create, and we should care for it. It should be beautiful. It should be clean, working, simple, really understandable. And the framework jail is something that is really popular in Java world, especially, is that you pick the frameworks and you start depending on them, and then you get into the jail, basically. So you cannot change many things because the framework controls you, and not you are controlling the framework. So be free. You can use many frameworks, but be sure that you control them, so you can replace any of the frameworks at any time. Very often it means that you're introducing the simple layers or facades in your code in front of the other frameworks, so that it will be easy to replace it if it's not maintained anymore, or it's buggy, or you don't like it anymore, or whatever. Or there's another solution that we did as well, so you just adopt it and you become the committer and maintainer of this framework. In this case you again control it, and it's also okay. So start your code from the main method again in Java, not from the application server that controls you. And every dependency should be replaced, as said. And there is another interesting topic called the software erosion. So this is something like, it's not something beautiful like this in the Utah state of US. It's mostly something like that. So then something worked before and it stops working. It's really common in our profession. So in old Hacker's dictionary from the 1980s, there was a term bit rot, and they were making fun of it. Is that when people say, hey, this software, it was just lying there, but it doesn't work anymore. It's because of the cosmic rays that actually flipped the bits on the storage medium, and that's why it's now broken. So that doesn't happen in reality. So what really happens is that you just break it, or the environment around it actually changes. So Uncle Bob actually, and this is when it's dormant. So there are actually two types of software erosion. It's either active, then you are actively making it worse, or there's dormant, when the environment around it changes and it no longer works in this environment. Both are pretty important to handle. And Uncle Bob said again recently is that software should get better over time, but for some reason many people accept that big projects that have lived for many years, people expect them to be bad. They expect the code quality to be worsening all the time with more developers working on it. So that is an active bit rot, something then you're actively making it worse. So don't do that. Just clean up your code, care for it, make it more beautiful, make it better all the time, not worse. And the dormant one is something when you depend on the environment too much. And this is where the Docker or this kind of environment controlling tools can help you. So Hiroko said that the explicit contracts, like what Docker does with your app, that you just listen to the port, you just start up the process in a controlled environment. This is something that fixes this part. But this part is something that we actively break. And one of the last things is the type safety and refactoring. So constant refactoring is something that prevents active erosion. This is what you should do every day. Every line of code that you make, every feature you add, you should think, maybe I should clean up something, improve the design before adding it. And type safety is something that enables automated refactoring. So I'm pretty happy that in Java it's really easy, and Kotlin as well, my favorite language, it's really easy to do the big scale refactorings, even if when it seems like too late, you still can do that in most cases. And if you're relying like on dynamic languages, it can be much harder. People just don't do it. They say, hey, I'm pretty happy with my dynamic language, I just don't refactor. That's why it's not hard. And yeah, people avoid doing things that are not easy. And of course, serious JavaScript development is already moving to TypeScript. A lot of bigger companies, startups who work on Node, they now do TypeScript. Python has added type hints just for the same reason. And of course, in our Java world, it's just there. And well-crafted software is something that's actually meaning that you're doing it professionally and skillfully. So this is the clean code, the refactoring, the tests, everything I was mentioning. And basically it's also caring about your work and your colleagues. So you're not making their lives more miserable, even after you quit or you get hit by a bus. So you're maintaining it always in working order. So it's always working software, and you design it in a way that it will not break easily by itself, like software erosion. So you always implement the simplest solution possible. Sometimes it takes effort to find it, but it's always worth it. And don't listen to Stack Overflow too much. Very often Stack Overflow says that this is how you do it, and there's no other way. And in most cases there is a simpler and more elegant way of doing things. So Stack Overflow is actually pretty bad, Stack Overflow based development. So there's also a phrase in extreme programming, yagni, you ain't gonna need it. So this is sometimes help to tell your colleague, explain your point. So you just say yagni, and maybe you should delete some of the classes that you don't need right now. And that brings us to the iterative process, what the agile software development is. And basically it meaning that our customers, they probably never know the best way how to solve the problem, or what to do and how to do. And what we can do, we can help them by demonstrating working software frequently. So basically every week, every day, all the time our software is working. They can touch it, we can together think what is the better way to go next and develop a software that is actually relevant and for the end user and everyone. And the perfection is achieved not when it's nothing more to add, but when there's nothing left to take away. Very old wisdom from Antoine de Saint-Exupéry. So if you follow these things, we can craft really good things, and maybe like this is how you do it. So thank you for listening.